Okay, so back for another round of testing. I have another pair of functions that will graphically check. Again, looking at C, I can kind of get a feel that they're not going to be inverses, because if I was going to reverse the fourth, raising things to the fourth power, I'd expect to see a fourth root. And if I was dividing by x, I'd expect to be multiplying by x, but it seems to be happening here. So I kind of going into this, it doesn't look like they're really reversing what each other does. But let's just go ahead and officially check. So if we look at the composition, F composed with G, right, that's what that means. So we're going to put 1 over x into F. So where that x is being replaced by 1 over x. So we get 1 over x to the fourth power. Of course, we can take that power and apply it to the top. 1 to the fourth power is 1, and x to the fourth power is x to the fourth. So right away, right, we know that they are not inverses, because this is not equal to x. So I can basically stop there. But there is something that interesting happens here. If we do reverse this, all right, so let's just keep practicing this, right? So we're going to take g of f of x, which means we're looking at g of x to the fourth. So that is going to go to that x right there. So when we do that, what we end up getting is the same thing. So this is a very unique situation where the compositions actually do equal to each other, but they're not inverses, because in order to be inverses, they have to be equal to x. So we can definitely see that's not happening here. And then just even ordered pairwise, right? If we looked at f of 2, 2 to the fourth is 16. But if we looked at g of 16, we get 1/16. So again, that's not happening as we are supposed. And then obviously graphically, if we looked at this, right, there's y equals x, right? There's the graph of x to the fourth, right? And here's the graph of 1 over x. Clearly, right, they are not reflections of each other, right, through the line y equals x. So we know without a doubt, right, just from when we started and we were kind of just observing it, algebraically going through our composition, right, numerically looking at an ordered pair, right, and then just graphically, these are definitely not inverses, right? That's just, they're no go. All right. Next set, again, we kind of see some things happening, right? We're squaring and we have a square root. We're adding 4 and we're subtracting 4. So this looks like a pretty decent candidate to be inverses, right? So let's just see what happens when we go through our math. So we're going to first look at f composed with g of x. And so this means we're going to put negative square root of x minus 4 into the x right there. So that becomes negative square root of x minus 4 squared plus 4. When I square a negative, it becomes a positive. When I square a square root, the square root goes away. So we're left with x minus 4 plus 4. And lo and behold, we end up with x. All right, so far, so good. If we try to go the other way, right, then we get f of x. And this is equal to g of x to the fourth plus 4. So that means I'm using this as the input there for my x. So I get a negative square root of, that should be a squared, x squared plus 4 minus 4. The 4's cancel out, so we have a negative x squared. The square root of x squared is in fact x, but this is actually equal to negative x. So at the moment, right, the answer would be these are not inverses. Again, even if we looked at data, right, if we looked at f of 1, what we're going to get is 1 squared plus 4, we get 5. If I looked at g of 5, we'd get negative square root of 5 minus 4, which is the square root of 1. And what we get is negative 1. So 5, negative 1, 1, 5. They don't appear to be inverses. All right. So again, we were kind of. How about this? We can kind of get a feel that that right undoes, or excuse me, F undoes what G does, but G doesn't quite undo what F does. Right. So it's almost like a half inverse, but not a full inverse. All righty. And again, graphically, if we were to look at this, all right, here's the graph of x squared plus 4. It's essentially our parabola, right, that is being shifted up 4 units. And then here's the graph of the other guy, all right, the square root of x minus 4. All right, and what's interesting about this, earlier in our conversation about inverses, I mentioned how this is not a one-to-one function because it doesn't pass the horizontal line test. But if we were, right, I forget how to do this on decimals. Let me see if I do it this way. X less than 0. Check this out. Alright, so if I, yeah, it doesn't do that. But if I was, we're going to restrict the domain. And I don't know how to get decimals to do it. Sorry about that. But if we were to restrict the domain, I want you guys to kind of see something here. Right? If I was to take this part away right here. Right? So if I basically looked at this function for x less than 0. Right? So we imagine we took that part of the graph away. And let me try to do that with my thumb since I can't get that done. Notice that that red part does in fact, right, have a mirror image with that part right there. All right? And so what we do, we kind of have kind of a half inverse with regard to all this, which is also what we're going to say. But it has to deal with the fact that this function isn't one-to-one. And as I mentioned to you guys earlier, what we do with the function that's not one-to-one is we actually take part of it away so where it does behave one-to-one. And then if I have that action where it behaves one-to-one, I do in fact have an inverse. All right? And amazingly, right, if we were to finish this graph off, right, this is a parabola laying down, it would be going this way, and that would be symmetric with the other graph right there. So we do have some nuances going on here. Back to the problem right now, I would say that they are not inverses because it didn't pass the test. It doesn't pass the numerical test, and it doesn't quite pass that. But if we do start restricting domains, then the answer becomes yes. All right, so more nuance. I'm going to keep building up through that at you, and we'll take a closer look at it. So sometimes, even though we have an answer of no, right, the answer might be yes if we play around with the domain. All right, but more on that later. There's kind of a second glimpse at a weird one-to-one function situation that we can work around. All right, but as at the moment, right, if I was, without any restrictions like I did there, the answer is no. Right, it didn't pass the test. All right, so let me cut to another video and we'll do some more examples and we'll see some things in action.